friends, now in continuation to my video of electric charges and fields, now I will discuss about charge and mass. So before going to charge and mass, we know that there are two forces, gravitational force and electrostatic force. So for gravitational force, the mass is important, and for electrostatic force, the charge is important. So we'll talk about the charge and mass. So one is charge and one is mass. Now there's a big comparison between the two quantities, charge and mass. We see that charge is positive and negative, whereas we know mass remains positive. Okay. Second is charge is conserved, whereas the mass is not conserved. Now laterly we will come to know why mass is not conserved, but this mass is not conserved and it evolves in the form of energy also by the explanation of Einstein's relation delta mc square. Third thing is that charge is independent of what? Speed. Whereas mass depends on speed. Okay. Charge can be quantized. Now already we have gone through the quantization where we say that Q is plus minus Ne. But mass cannot be quantized. It remains continuous. It can't be discrete. So these are the comparison in which we see that a charge represented by Q and mass represented by M. And this independent of speed and mass depends on speed is a very important property. Even this property is also known as invariance of charge. Okay. So charge and mass, two different quantities, and we know that a charge has a mass, but mass, it's not necessary that mass will have a charge. Okay. Like we know that neutron. Now we know a neutron has a mass, but it doesn't have what? Charge. Okay. So now we'll talk about the very important law, and that is Coulombs electrostatic force. That is also known as Coulombs law. Now what is Coulombs law? Very simple. There are two charges. Say one is Q1 and another is Q2. And the distance between the charges is say R. So what is Coulombs law? So very simple, according to Coulombs law, the electrostatic force between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. Okay, so this is Coulomb's law of electrostatic force. Simply, if I say F is directly proportional to Q1 Q2 and F is inversely proportional to R square, if you comprise them, it will be Q1 Q2 by R square, and finally what you get is that F is K Q1 Q2 by R square. This is Coulomb's law between 2 point charges. Q1, Q2 are the charges, R is the distance. And remember, this is the electrostatic force. And you know what was the gravitational force? Was G m1 m2 by R square, which you have gone through in class 11th. This was gravitational force, just for your memory. So we will compare them also. But right now, this is the electrostatic force. Now, F equal to K Q1 Q2 by what? R square. So this is electrostatic force in air medium. Even we can represent like air, because we are talking about the air or the free space or the vacuum. So this is the force in the air medium. Now this K, which is small k, it's a Coulomb's constant. Okay, and we also say it as electrostatic constant. And then how we write the K, the complete elaboration is K is actually 1 upon 4 pi epsilon naught. Now here the value for the K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, and this 4 pi is actually a constant. This epsilon naught, this is like a E naught, it is known as epsilon naught. It's a Greek term, epsilon naught. Now what is this? It is actually the permittivity. The name is permittivity of free space. It's a constant. That means electrostatic force depends on a medium. In different medium, it will behave in a different way. So the force will be 1 upon 4 pi epsilon naught Q1 Q2 by R square. So this is the force in vacuum or in air medium, which is like this. So K has been replaced by 1 upon 4 pi epsilon naught, and its value is 9 into 10 to the power 9. Now this epsilon naught is also having a value 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Free space or in air medium, and it will be given in the paper. So we can use this constant. And if you remember this K in gravitation, you remember it was G m1 m2 by R square. Remember it because we have gone through it in gravitation. So this is electrostatic force. Now if I will give you an example here. If I have two charges, like say one charge is of 1 microcoulomb and another charge is of 2 microcoulomb, and they are separated by say 1 meter. And the question is very simple, that find force, electrostatic force between two charges in air medium. So very simple. It's a simple example. How we are going to do it? We know that F, it's K Q1 Q2 by R square. What is the value of K? 9 into 10 to the power 9. What is Q1? 1 into 10 to the power minus 6 microcoulomb. Then Q2 is 2 into 10 to the power minus 6. And R is 1 square. So you solve it out, it becomes 9 to 18 and then minus 12, and 9 is 18 into 10 to the power minus 3 Newton. So simply this force is in air medium, and this is the force between two charges. So we can find out such forces in different mediums. But what happens if the medium is different? So we'll talk about that if the medium is different, then how this force behaves. Now, if any other medium is present between the two charges, do you know any other medium is denoted by epsilon? What is epsilon naught in a free space? Epsilon is permittivity in any medium. You can have any medium. So that means force in any medium or a given medium will be 1 upon 4 pi. In place of epsilon naught, it will be epsilon. So Q1 Q2 by what? R square. This is the force in a medium, which is a given medium. Now, do you know a very interesting thing is that this epsilon can also be written as epsilon naught into epsilon r. If you ask what is epsilon naught, it's in free space air medium. This is in medium. What is epsilon r? It's the relative permittivity. Remember relative density, relative refractive index. You can relate medium into air medium. It is just like that. So epsilon r is literally termed as capital K and also known as dielectric constant. It is given for mediums. So it is also known as dielectric constant. So this is a very important thing, that Fm, force in a medium, will be written as 1 upon 4 pi. In place of epsilon, you can write epsilon naught into epsilon r, Q1 Q2 by R square. Now in place of epsilon r, you can write K. So finally, it is 1 upon 4 pi epsilon naught capital K Q1 Q2 by R square. And if you see this force, it can also be written as F air by what? K. You know, capital K. So I think you got it. How? Because F air is already what? 1 upon 4 pi epsilon naught Q1 Q2 by R square. In this way, you can define dielectric constant as F air by F medium. So this is another definition of dielectric constant. A dielectric constant. And you know, here also epsilon r can be written as epsilon naught upon epsilon naught. It is also a dielectric constant. So in a two-way, you can define a dielectric constant. And from this also we know that Fm is actually less than what? F air. So this is how we talk about the force in any medium, and this relation, it is generally asked in board exam also, that how you define Fm, F air by K. And if the same numerical I take here, and if I ask you that it was in air medium, now the same thing, find electrostatic force, okay, in dielectric medium K equal to 3. That means between these two charges there is a medium K equal to 3. So what will be the force? Do you know? You can directly write F m equal to F air by K. What do you got in F air? It is 18 into 10 to the power minus 3 by 3. So calculated, it becomes 6 into 10 to the power minus 3. So here we see that this is a force in a medium which is less than what? Air. So same question was asked in air medium, if you see, and same is asked in dielectric medium. So how the formulas are interrelated? This is the electrostatic force between the two charges in any medium. Now I will just discuss some characteristics of electrostatic force. Now when we talk about electrostatic force, there are some characteristics. What are those? We see it's a central force. I think you remember gravitational force was a central force. It is also a central force because it acts between the center. You have a charges, you take a distance from the center. Always remember Q1, Q2, you take the distance from the center only. Then it is a inverse square law. You know that gravitation was also inverse square law. Then electrostatic force is repulsive and attractive force. You remember gravitation was only attractive force, so it is repulsive and attractive force. It's a central force. It is a conservative force. You remember conservative force, under which the work done is independent of path. So central force, inverse square law, repulsive and attractive force, conservative force, and it follows superposition principle. So these are the main characteristic of the electrostatic force. Okay.